All right, in this example, we need to name the degree of the polynomial. So what that implies is that the degree implies that we look at these numbers up here, 4, 3, and 6. And the name of the polynomial is the highest of those exponents, which would be 6, because that's the largest. Okay, so we would say that the degree of the polynomial is 6. This is a 6th degree polynomial. Okay, so in this one, we need to, again, name the degree of the polynomial. So we're going to look at 2, 5, 4. This one doesn't have a degree on it. Well, it does, but it's hidden. This one has a 1, and this one has a 3. So which is the highest polynomial? That one. So this is a 5th degree polynomial. There we go. In this example, we need to simplify each polynomial expression. So that means we need to look at, here's my first polynomial, here's my second polynomial, okay? And I need to look at what I'm doing with them. I am adding them together. So that just means that I get to take this one as it is. So I get to take plus 6p minus 8p to the 4th power plus p cubed. And then we're going to just bring this one down. 2p minus 5p cubed minus 5p to the 4th. And then I'm adding a plus 6p and minus 8p to the 4th and a plus p3. So let's find our like terms. Okay, that's the biggest one. We're going to combine like terms right now. So is there another just a p term? And it looks like that's right there. So I'm going to do 2 and the 6. So that's 2 plus 6, which is 8. Keep the p on it. Now we're going to take a look at my p cubed. Is there another p cubed? There certainly is. There's this negative 5p cubed, and there's this plus p cubed. So that's a 1p cubed. So to do that, I do negative 5 plus 1, which is negative 4, and they both had a p cubed, so I'm going to keep that. Now we look at my last term. We're done with that, that, and that. So now we got to look at negative 5p to the 4th minus 8p to the 4th. If I take a look at combining those, I get negative 5 plus a negative 8, which turns out to be negative 5 minus 8, which is negative 13, and they both had p to the 4th. And now we got to write it in standard form. Okay, which is highest exponent to lowest. So between these three, p to the 4th is the highest. So we're going to start with negative 13p to the 4th. My next term is negative 4p cubed, so minus 4p cubed. And then this 8p right here is a positive 8p. In order to have a complete expression, I need to have minus signs in between each of my terms. All right, in this example, again, we need to simplify each polynomial expression. So the nice thing about this one, it has a plus sign in the middle. That plus sign means that I just have a plus 5 plus 2n to the 5th minus n to the 4th. All right, so now I'm going to bring down my other expression, the leading expression. So that's 6n to the 5th minus 6n plus 6n to the 4th minus 2. And now I have a complete expression. So we're going to combine like terms now. We're going to combine like terms. We're going to look at 6n minus 6n to the 5th, and we're going to look for another n to the 5th, and that's plus 2n to the 5th. So that's like saying 6n to the 5th plus 2n to the 5th. Now these aren't exponents, so we don't get to add the exponents. We just get to combine the coefficients of 6 plus 2, which is 8. and then we keep the n to the 5th. My next set of like terms, let's see if we can find one that matches this, negative 6n. So we're going to look just for another n, and looking, and I don't see it. So actually that one stays alone. So then we have minus 6n. Okay, now we're going to look for pairs that match with plus 6n to the 4th. So we're looking at n to the 4th, and here's another n to the 4th right here. All right, so that is like saying 6n to the 4th minus n to the 4th. And what you have to remember is that you can put a 1 right here. So you have 6 minus 1. So you have 6 minus 1, which is 5, and it's a positive 5, n to the 4th. And now we look at our last two numbers, which is negative 2 plus 5. And those are indeed like terms. So we can combine them. Negative 2 plus 5, negative 2 plus 5 is a positive 3. So plus 3. And now we're going to write it in standard form. Okay, in standard form, it's the highest exponent. So that is 8n to the 5th. Then we have our next exponent after 5 is 4. So plus 5n to the 4th. And then what we do not have is we do not have an n to the 3rd, n to the 2nd, but we do have a negative 6n. And then we have this last term, which doesn't have an n, so plus 3. And there's our answer in standard form. All right, so in this example, we need to simplify each expression. So again, we have a polynomial plus another polynomial. But that doesn't mean we just get to add each term. That means we got to look and do what the signs tell us to do. So we're going to take care of this plus sign, and we're going to make sure that we don't change anything inside. So plus and a negative gives me a negative 6x squared. Plus and a negative 5 still gives me a negative 5x to the 4th. And a plus and a negative 2 still gives me a negative 2. We're going to bring down our other polynomial, negative 8x to the 4th plus 3x squared plus 7x cubed minus 7 minus the rest, this other polynomial. So now we're going to start with combining like terms. All right, so we're going to look. Here's my first term, negative 8x to the 4th. So let's find another fourth term, or x to the 4th, which is right here. So that is negative 8x to the 4th minus 5x to the 4th. So negative 8 minus 5, that's negative 13x to the 4th. All right, next term in line is 3x squared. Is there another x squared term? Oh, certainly is right there, negative 6x squared. So we're going to take 3x squared, which is a plus 3x squared, minus 6x squared. So 3 minus 6 is negative 3x squared. Now we move on to our next term, which happens to be 7x cubed. And there are no other x cubed terms, so we're just going to leave him be. All right, and now we're going to look at our last number, which is negative 7, which pairs nicely with this negative 2. So that's like saying negative 7 minus 2, which gives me a nice negative 9. Now we're going to put it into standard form. All right, standard form simply means highest exponent first. So highest exponent, we're going to put negative 13x to the 4th. Then we're going to put the next one, which is a 3, so that's plus 7x cubed. And then the next one is minus 3x squared, and then minus 9. And then we're done. That is in standard form. All right, so in this example, we are going to look at combining these two terms. And we have to be very careful because when I look at this, I see a minus sign in between those two terms, these two polynomials, which means that that's a minus 1 times this, which means I'm changing the sign of everything inside. And how we do that is we distribute a negative 1 through, to here, to there, and to that one too. All right, so I get negative 1 times 5, which is negative 5b, negative 1 times negative 5, which is positive 5b cubed, and negative 1 times positive 3, which is negative 3b squared. Now we bring down b squared minus 3b to the 4th plus 4b minus all of that. So now we're going to combine like terms. All right, so if we look at our terms, we see a b squared here, b squared, where do I see another b squared? Oh, right here, minus 3b squared. That's b squared minus 3b squared. And that's a 1b minus 3, which is minus 2b squared. Now the next set of like terms is a minus 3b to the fourth, and no other b to the fourth, so we're just going to bring it down, minus 3b to the fourth. Now we're going to move on, and we're going to look at plus 4b. Is there another b term? Yep, minus 5. Okay, so that's plus 4b minus 5b, which becomes negative 1b. 4 minus 5 is negative 1. And then we're left with this last little only 5b cubed. So 5b cubed. Now, to finish the problem, we have to put it in standard form. Which, to put it in standard form, start with the highest exponent, which is 4. So that's negative 3b to the fourth. Next one after that is a 3, so 5b cubed, so plus 5b cubed. After that, we have the next after 3 is 2, so negative 2b squared. And then finally, leaving me with minus 1b. And there it is in standard form. All right, for this one, and again, I need to be cautious of it to simplify this one because of the minus sign right there. If you remember, that means minus 1. So I'm going to distribute a minus 1 and distribute yet again. So that's negative 2n to the fourth. Negative 1 times negative 5 is plus 5n to the fifth. Oops, let me clean that up a little bit. Okay, 5n to the fifth. And then negative 1 times positive 6 is negative 6. Bring down the rest of it. Negative 5n to the fourth plus 5n plus 6n to the fifth plus 7. All right, so now we're going to combine like terms. So negative 5n to the fourth, we're going to look for another n to the fourth. N to the fourth, and there we see it's n to the fourth. So I have negative 5n to the fourth minus 2n to the fourth. So negative 5 minus 2 is negative 7n to the fourth. Then I'm going to look for any more n terms. So are there any more n terms? Nope. So he's all by himself, so nothing to combine him with. So we just leave him alone. Then we move on to 6n to the fifth. N to the fifth, n to the fifth. Oh, right here. So I have plus 6n to the fifth plus 5n to the fifth. 6 plus 5 is plus 11n to the fifth. And now we see that, hey, I got a plus 7 and a minus 6. So plus 7 minus 6, well, that's plus 1. Now we got to put it into standard form. So the highest exponent among all of my terms is the n to the fifth. So I put that whole term first. So I have 11n to the fifth. Now we move on to n to the fourth, which is right here. So minus 7n to the fourth. There's no n third, there's no n cubed, so we bring down the plus 5n, and we leave off with plus 1. And we're done. All right, for this example, we need to combine these two polynomials again, and now we see that there's a minus sign in between. So you got to remember that that means that right there, that's a minus 1. All right, so that means that's a minus 1. We're going to distribute negative 1 through. And really all that does is change the signs to the opposite of whatever they are. Negative times a negative is a positive 7r to the fourth. Negative times a negative is a positive 6r squared. And negative 1 times negative 5 is positive 5r cubed. Now we bring down the other leading polynomial, which is negative 7r cubed plus 7r squared minus 2r minus r to the fourth. And then we have all of those. Now we're going to combine like terms. Let's look. Is there another r cubed term? Not here. Oh, right there. So we take negative 7 r cubed plus 5 r cubed, which is negative 2 r cubed. Next, we are going to tackle my r squareds. Is there another r squared? Certainly is, right there. So I take plus 7r squared plus 6r squared. 7 plus 6 is plus 13r squared. All right, now I have minus 2r here. Is there another just r term? Nope. So I have minus 2r. Now let's check for r to the fourth. Yep, right there. So we take negative r to the fourth plus 7r to the fourth. That's a negative 1 plus 7 is a negative 6 r to the fourth. So I've combined all of my like terms, and now I need to reorder everything into standard form, which is highest exponent first. Highest exponent is this, negative 6r to the fourth. Next, after 4 is 3, so minus 2r cubed, and then we have our exponent of 2 next, so plus 13r squared, and then our last guy, minus 2r. And we are done. That is simplified and in standard form. And now we need to name the degree of each polynomial. So we got to find the highest exponent. The degree is the highest exponent. All right, so that means we take 5, 4, 3, and there's a 1 there. Got to be careful. And then 2. And the highest exponent among all of those is a 5. So this is a 5th degree polynomial. All right, in this example, we need to name the degree. So we look at our degrees. 1, this is 2. I can actually put an exponent of 1 right there, and then 4. So 2, 1, and 4, between all of those 3, 4 is the highest. So we'll call this a 4th degree polynomial. And that's it.